All right, we'll go ahead and get started in the interest of time. Hi, everyone. Thank you for joining us today. My name is Isabel McCann. I am the communications lead for the Global Power System Transformation Consortium, or the GPST. The GPST is hosting today's webinar. So thank you for joining us for the webinar on IEEE Standard 1547, Distributed Energy Resource Requirements and Implementation to Interconnection Processes. So before we get started today, I am going to cover just a few quick housekeeping items. So just for everyone's knowledge, the workshop today is being recorded. It will be shared with attendees and it will be posted to the GPST YouTube channel. I believe that IEEE will also have the deck and the resources available as well. If you need to adjust your audio, if you're having any audio issues, you should see at the bottom of your Zoom toolbar, there is an audio settings. If you select that for your computer audio, just check your sound and sound output and volume. Make sure you don't have a Bluetooth speaker somewhere that it's coming out from. Or if you dialed in by phone, dial-in numbers can be found in your registration confirmation email. So if you're having any issues with audio, if you tried computer audio, I'd suggest trying dial-in. If you tried dial-in, try computer audio, just swap your audio option. So to ask a question today, please use the Q&A function. Zoom does have a dedicated Q&A function. If you, again, hover over your Zoom toolbar, you'll see that Q&A function there. If you open that up, just type in the question and select send. There is also a chat function. So if you want to make a comment, please use the chat function and send it to everyone. You can also send it to specific people on the panelist and host side. But we are trying to keep the chat function fairly clean. So if you have a question for the panelists, please use the Q&A function. And to that end, we will have at least 15 minutes or more for Q&A at the end of the presentations, but you're welcome to send in your questions at any time. We'll keep an eye on them, and when we get to that section, we'll go through and address the questions that have come in. So before we get started with the technical presentations, I do want to share a little bit about the GPST consortium and who we are and what we're doing. So the GPST is a new global consortium focused on support to power system operators with advanced and low emission solutions. The consortium is comprised of championing founding system operators, which you will see at the top of the pyramid there. They are leading a research agenda group to identify common and cutting edge research questions that can inform large scale national research and development investments. You'll see at the bottom left-hand corner is we also have a core technical team actively developing the consortium and engaging in the implementation of the technical work. And then on the bottom right hand, we are also partnered with several emerging economy system operators such as Indonesia's PLN, NLDC in Vietnam, PASOCO in India, and several others. So, the consortium is really built on the vision of developing and disseminating the technical and engineering knowledge to support the global energy transition at the speed and scale required. So that's just a little bit about the GPST consortium. And I do want to just also mention how you can engage with us. So globalpst.org, that's where you're going to be able to find this recording afterward, and just where you're going to be able to find the library of all of our other webinars. We have webinars on all sorts of different topics. And if you want to receive event and training invitations, our newsletters, any other important updates, you can do so on our Get Involved page. We also have a regional peer learning network, pillar groups. I didn't go into all of our 5 pillars today, but if you visit the globalpst.org website, you can see our 5 sort of pillar thrusts and pillar focuses. So we have community of practices, peer learning networks. Again, all you need to do is visit the Get Involved page and enter in your information there. And if you do have any questions for us, or if you want to reach out to us directly or explore any sort of remote light touch technical assistance, you can do so by emailing globalpst@nrel.gov. So again, thank you all for joining us today, and I'm listening to a little bit about the GPST. So with that, I will go ahead and introduce today's speakers. So on the line with us today is David Narang, who is the Principal Engineer in the Power Systems Engineering Center at the National Renewable Energy Laboratory, or NREL, in Golden, Colorado. So David supports the development and adoption of DER interconnection and interoperability standards and served as the working group chair for the 2018 revision of IEEE Standard 1547. Prior to joining NREL in 2015, David spent 14 years working as an engineer at an investor-owned electric utility in the Southwest US, focusing on renewable integration. We also have Ravi Subramaniam, who is currently serving as the director for the IEEE Conformity Assessment Program. In this role, Ravi advises and consults for numerous working groups on post-standards implementation, which encompasses test plans, certification program development, and interoperability. Currently, he is focused on developing programs and interconnection of DERs, digital resiliency and security, EV charging, autonomous vehicles, blockchain and sensor technologies. He has helped form and support the IEEE Synchrophaser and IEEE 1588 Power Profile Conformity Assessment Steering Committee, and serves as the secretary of IEEE's Nuclear Power Engineering Committee Conformity Assessment Steering Committee. Those are a mouthful of committee names. So prior to taking on this role, Ravi served in various technology management roles across the globe, and he has worked previously for MET Eurofins, Honeywell, and Ericsson. He studied electrical engineering at Arizona State University and Johns Hopkins University, and has a mini MBA from Rutgers University. So with that, I will go ahead and hand it off to David for today's first presentation. So I'll go ahead and stop sharing, and David, you can take it away.
Okay, thanks a lot. Let me figure out how to share the right screen, and it should be this one. Can you please confirm that you're seeing the presentation view?
Yep.
Fantastic, thanks a lot. Good morning, everybody. As you heard, my name is Dave Narang. I'm delighted to be here. Thank you very much for joining. I'm coming to you from my virtual office location here at NREL. I'm here to give you a high-level view of some of the highlights in IEEE 1547 standard, and also share some considerations as we look to implementation of the standard. Once again, many thanks to the audience members who are with us today. I hope you find today's webinar informative and your time well spent. Thanks also to Isabel and our other webinar organizers who've given me the chance to speak with you today. This slide is shown to acknowledge the contributions of many others who've worked on the standard as part of the working group, balloters, and the working group officers, as well as support from the Department of Energy that allows my participation in standards development. So almost everyone will have their own version of this slide that talks about DER integration challenges in a modern grid. I borrowed this one from my boss, Ben Kaprowski at NREL. I'm not going to go into too much detail into this, other than to say that as our energy system evolves, we hope to gain flexibility through all of these advanced technologies, but there are also a variety of challenges to overcome. And this slide lists some of those challenges and considerations. For example, new energy technologies and services, increasing amounts of variable energy, new communication and control methods, and of course, a big part of the challenge is integrating distributed energy resources such as PV, energy storage, and other technologies. The value, I think, of 1547 is that it helps us to standardize these modern DER performance capabilities in these devices to enable this power system transition. And we can use 1547 to move us from just accommodating DER to integrating them as grid assets. And in the end, better standards help us to lower the cost of doing business while maintaining what I would call robust engineering controls for all of the things we care about technically. So for the folks who are on the call that may not be familiar with the IEEE standards development lifecycle, I've added this slide to highlight some of the major parts of the process. And this is a process that can take up to 4 years because we typically have to achieve consensus among a large number of participants. And in a large standard like 1547 with a lot of different parts, there's a lot of material to cover. The major steps are, as you see on the top, starting with an idea for standardizing something, development of the project authorization request that goes to IEEE Standards Board for approval of the project, choosing the project sponsor that will help shepherd the project through this entire process. Once approval is gained, pulling together the working group members that will spend possibly years collaborating to develop the draft content in the standard. Once that's completed, as you see, this could be, once again, iterative process. There's a public balloting process that's open to everybody, not just working group members. In the case of 1547, this public balloting process had over 383 balloters. Once that achieves a suitable level of consensus, and the benchmark is 75%. In the case of 1547, the consensus was over 93% in agreement of pushing the standard forward for consideration by the Standards Board to make it a standard instead of a draft. Once that approval is done, IEEE publishes the standard and we go into a maintenance cycle that can last maximum of 10 years, after which time we have to decide whether we want to revise the standard or supersede it or withdraw it. So in a nutshell, that's the process we went through for developing 1547. So what is 1547? This slide attempts to very compactly show the scope and purpose, and on the drawing on the left of this slide, you see the distributed energy resource box on the left. By DER, we mean all of the equipment needed to meet the requirements of the standard. In kind of this right area, you see this area EPS, that's the area electric power system, the distribution grid, basically. This dotted area, shaded area is what the standard is focused on. This is called the interconnection system. And that term means all of the equipment and functions taken as a group used to interconnect the DER to the area power system. Key concept here is that in this revision, the interconnection system has not just a power interface, but also a communications interface. The standard applies to all types of DER, including synchronous generators, induction and inverter-based resources interconnected to typical distribution voltages, regardless of their size. So although this standard establishes criteria and requirements for interconnection, there are some things that it is not. For example, it's not a design handbook. It's not an application guide. There's another standard, 1547.2, that is an application guide that's in the process of being finalized right now. It does not take the standard, does not take the place of interconnection agreements. There's a whole lot more going on in interconnection agreements, potentially, that we'll talk about later in the slide deck. And the standard doesn't cover everything that might be necessary to maintain and manage the grid or other important functions, for example, cybersecurity, although these are very important functions. And one other thing, the standard does not apply to resources directly connected to the bulk power system. That topic is covered in a new standard that's currently in ballot, IEEE P2800, 2800, and I'll talk a little bit more about that coming up in another slide. So this slide that you see on the screen shows the intended use of 1547 with related standards. On the left is an outline of the major content areas in 1547. On the right is a set of standards that are closely coupled with the 1547 base standard. On top, you have 1547, kind of on the top left back, which gives us the technical performance, functional requirements we just talked about. The next box, IEEE 1547.1, as you see, gives us the conformance test procedures that will help us to verify that the DERs can meet the requirements, the technical requirements in the standards. Next, we show in this yellow box UL 1741, which is a standard that gives us the certification that the interconnection equipment, including the DER, meet the performance and safety requirements. So UL 1741 runs through all the tests specified in 1547.1 and adds safety features such as for equipment construction, protection from injury for persons, and so forth. The gray box on the right shows the NFPA 70, also known as the National Electric Code, and we've listed some of the articles that in that code ensure that the certified equipment will be installed correctly so as to meet the performance requirements. So these four standards are coordinated and are intended to be used hand in hand to provide the assurance that we get, once again, what we asked for. And while these should be sufficient for most installations, local jurisdictions will typically develop their own interconnection rules that have been codified in interconnection agreements. This slide is really an attempt to show the relationships of some key entities that have a stake in how the standard gets implemented. If we start on the right, we have the consumer or DER operator, and this is obviously where the DER is. We've got an oversight by this term AHJ, the authority having jurisdiction, and you see what the inspection and approval responsibilities are. Moving to the left, we have this level of the distribution system where a couple of entities are key here. The term that 1547 uses is the authority governing interconnection requirements. And as you see listed on this screen, this is the entity that really makes the rules for interconnection. And typically, this is the local or state level public utility commission. Like it could also be a municipality or a cooperative board for municipal utilities and so forth. The other entity that's important here is, of course, the electric utility in 1547. This is known as the area electric power system operator. Moving higher up the chain to the left here, you have this broader transmission level coordinating function that's filled by the regional reliability coordinator. And this can have several manifestations, starting with NERC in the United States, and then rolling on down to regional transmission organizations and so forth that are all, and balancing authorities that are all working together for maintaining the reliability of this bulk power system. So this slide attempts to provide some context on the requirements in 1547. So the boxes in the middle that with the blue and kind of this yellow are the 1547 requirements. The blue ones you can see are colored, for example, safety, power quality, protection, testing and certification, voltage regulation. These are all typical utility concerns that can be handled by the area EPS operator. And some of the decisions that they will have to make, as you see on the just to the right of these blue boxes, are shown on the screen. For example, protection, several types of studies, and evaluation of DERs. Now, these other two boxes, for example, interoperability and support for bulk system, or grid support functions have applications beyond 1547, as shown on the right, for example, to grid modernization. And because of that, we have to, or we expect that the utility or the area APS operator will work in conjunction with the authority governing interconnection requirements at the state level and potentially the regional reliability coordinator if those settings need to be reviewed and adjusted. So I'm going to spend the next few minutes talking just about the standard. I want to tell you up front that this is in this half-hour presentation. I'm not intending to and won't go into a lot of detail on the standard. If you have questions on it, please feel free to ping me afterwards. But this next about 7 slides are intended to just give you a high-level knowledge of the important topics that are at the heart of the standard. And we start with what I call good citizen behavior, and the DER has to be a good citizen first and foremost. That means it has to be safe and it has to provide clean power without trashing the voltage or current. And it has to play well with other equipment on the grid, such as load and other utility equipment. So these types of requirements have been reinforced in the current standard. Another key part of this revised standard is active voltage regulation capabilities. And this slide gives you a very high-level summary of what those are. This is probably the first grid support function that most utilities will likely want to enable. And this capability is required by the 2018 version of 1547. So note that the voltage regulation capability is mandatory, but the utilization of those capabilities are at the discretion of the utility and potentially other stakeholders like the Utility Commission. And I can come back to this slide if there are questions. Another area is ride-through. And so ride-through is the ability to withstand voltage or frequency disturbances. And there are multiple levels of capabilities depending on the type of DER that is installed. And so that's why you have these category 1, 2, and 3 type DERs that as you connect to the, as you go through the interconnection process, you kind of declare which type of category you are. And based on that category, according to 1547, these are the mandatory ride-through capabilities that the utility can expect will be capable, the DER will be capable of. So the main idea for this is to ride-through is to remain connected during temporary abnormal conditions. And this is essential at levels where we have high shares of DER, and because it makes an impact on both power systems reliability, stability. Utilization of these capabilities is probably going to happen gradually as distribution protection engineers coordinate with the regional reliability coordinators and gain fluency and trust in these capabilities. Okay, moving forward to the next slide. Another critical area of 1547 is interoperability. And this has to do with communications, which, as you know, is extremely valuable. So 1547 uses this term interoperability, borrowed from IEEE 2030. That means communication plus the ability to understand and act on the message. So you see on the top right-hand corner of this, what is in scope of 1547 is just, once again, that local communications interface that's related to that interconnection. Things that are downstream, for example, what happens inside the DER itself, depending on the type of DER or DER facility, that's out of scope of 1547. And then what happens upstream, for example, backhaul to the utility or aggregator or whatever, that's outside of 1547 itself. But at that interface, the DER, in order to meet these requirements, has to have these certain capabilities that you see listed on the bottom of the screen. And these all have to do with the means of communicating, the communications protocol. And there are three that are options. But the DER has to be able to communicate in at least one of these protocols, and can have additional ones, but they must be able to communicate in one of these three listed here. The other thing is the DER has to have the capability to exchange the types of information that you see here listed, like nameplate, monitoring, configuration, and management. And then we have some requirements for how good that communications link has to be, availability and read response and so forth. As I mentioned before, cybersecurity is important, but it was considered out of scope of this revision of the standard. Next, we get to high-level test and verification process. And as power systems come to depend on DERs for essential functions and services, more thorough testing and validation is going to be needed. But we have to remember to balance this need with the burden of testing. UL, I believe, if I remember my numbers correctly, estimates that more than 700 test files are produced to certify a single inverter under UL 1741-SA. This slide shows the high-level test and verification process in addition to the certification process. On the left, I show some general stages of the test and verification process. On the bottom, we have equipment conformance testing, then move up to interconnection review, then post-interconnection review and on to maintenance. For all the requirements specified in 1547, there are specific types of evaluations or tests to make sure the equipment is performing the requirements correctly. The colored boxes in the middle of the screen show the types of these tests, and on the right is a description of when these tests are typically done. And if a system changes drastically, a re-verification of these is going to be needed. The next few slides are, I'd like to introduce some of the increased complexity that needs to be considered as we go and think about implementation, especially in areas with high shares of DER. Of course, we have complexity in the standard itself. That's because of all of these new capabilities and requirements, we need to have more rigorous direction and requirements around these capabilities. And then, of course, at the customer facility, we have a more complex installation. This is what I would call, for example, a fully loaded interconnection that includes PV and energy storage and electric vehicle. And imagine several of these on a single distribution transformer, and then many more on a feeder, and we get to increased complexity at the utility level. And for utilities, 1547 is a good launch point for bigger picture goals of DER integration. The intent of the standard is to enable DER capabilities to help mitigate potential issues, sometimes from the DER installations themselves, and do that in a constantly evolving context in normal grid conditions and abnormal grid conditions. We can delve into this in more detail if we have time, but the main takeaway from this slide is that utilities have lots of experience dealing with the stuff that's in black text on this slide. All the right text is the new stuff they're going to have to deal with. And most of the audience will already know this information. At the end of the day, many utility business processes may be affected. So utilities are actively adapting to determine and develop kind of what is the new level of capabilities that they need to have internally to address these concerns. Then we have increased complexity at the bulk level. At high levels of DER deployment, especially with inverter-based resources, the most common, this may start affecting the bulk power system. And this slide lists a couple of the efforts underway to evaluate and provide guidance in these situations. As I mentioned before, the IEEE P2800 is a new standard in development, and it'll contain the requirements for inverter-based resources connected to sub-transmission systems. You see efforts ongoing by NERC, as you see here, and then several ISOs and RTOs, as I mentioned before, are already on their path to investigating how best to incorporate 1547 settings as it applies to them. Then we have increased complexity at the local regulatory level. Local jurisdictions, as I mentioned before, have the responsibility for interconnection rules, and they may work very closely with utilities to promulgate those rules and execute those rules. But typically, it lands at the State Public Utility Commission. And there are many considerations that are likely being juggled at that level, such as RPS goals, potential for DER aggregation, rules for new types of DERs, including energy storage, electric vehicles, and so forth. And potentially, as mentioned before, coordination with regional reliability managing entities. There could be impacts of 1547 on interconnection screens used by some utilities. Changes may be needed or to expedite it or supplemental reviews and full impact studies. And of course, interconnection study time and cost is a perennial topic of discussion. This slide shows just a snapshot of activities at various state levels around 1547 adoption and implementation. I've highlighted that in early last year, the National Association of Regulatory Utility Commissioners, NREL, published a call to action recommending that the new standard be adopted and implemented by all state commissions. So this slide tries to present some of the major considerations that will likely come up when updating interconnection rules. I've broken them down into three main steps, as you see here: pre-planning, developing the rule itself, maintaining, and revision. The approach suggested here is to try and first take a step back from the technical requirements themselves to get a better understanding of the broader context for the rule update. And this hopefully will help to develop a better sense of how to structure the process to gain the maximum benefit for interaction between stakeholders, and also coordinate the timeline for interconnection rule update with whatever constraints the PUC might be having, including coordination with other relevant procedures that might be happening, for example, grid modernization or net metering, or the things that have to do with some of these utilization of these capabilities. Then in step two, the suggestion is to put the 1547 requirements in context of other technical requirements that may be needed by the local utilities or the local jurisdictions, and also consider what other types of coordination may be needed across the jurisdictional boundaries. And this is really where the work of adopting the settings or adjusting them comes in, as well as adding some of, once again, some of those local requirements, such as for specific types of metering. The last step suggested is to figure out in advance what might trigger another update, and also consider how the rule itself is constructed so as to be maintainable. There are lots of places where you can get educational materials. This slide lists just two. Ravi's going to talk about work going on under ICAP about educational opportunities. The first slide here is an NREL site that catalogs material from other sites, and then there's another site at, as you see listed here, that's hosted by IEEE 1547 sponsor, and that also lists educational materials on some of these deeper technical topics that I've been talking about. So this is an attempt to list some of the efforts that are ongoing that are tackling important issues related to DERs. And a lot of these have to do with implementation of the settings, and other efforts have to do with things that were left out of the standard but are important. And the top one, of course, here is cybersecurity. And as I mentioned before, in the standard, as it was being finalized and even discussed, the standard was published in 2018. And this was acknowledged as a critical area, but considered out of scope for 1547 at that time because of the scope of 1547 itself, and then the complexity of the cybersecurity requirements, which we didn't think we could have consensus on, and then the many different types of system architectures, and of course the different types of cybersecurity considerations that go along with this. Now, since that time, a lot of work is going into this, and I've listed some of the areas where that's going on, and this is by no means an exhaustive list, of course. Another area of very active across all areas is interactions with bulk power system. As I mentioned before in one of my other slides, NERC is really probably spearheading a lot of this and putting out a lot of fantastic educational material on some of these topics and concerns. Unintentional islanding is another area. It seems to be a perennial topic of discussion, and it comes up on almost all interconnection rule updates. I just listed one working group under the California Rule 21, which is, I believe, at the end of this year, going to be forming a special, let's say, a working group just to tackle unintentional islanding and learn more about it and discuss more about it. Grid forming inverters is another area that I listed here, very active. 1547, 2018 does talk about intentional islands. I didn't have a slide on that, but it's a very important area, especially when it comes to resilience, and there's a lot of activity around this. DER aggregation is another area. Of course, FERC 2222 opens the door for aggregation from bottom up rather than top down. And I've listed a couple of areas where there's more information on that. Hopefully there are people in the audience who can provide a little bit more information on how this is actually playing out or about to be played out, moving towards implementation. Standards conformance, how to ensure standards are implemented properly. Robbie's going to talk a little bit more about that. And of course, there are many other areas of active research and development not listed here. This slide gives just a highlight of some of the standards efforts that are important for DERs themselves. Starting with standard 2030, this is the heart of the interconnection and interoperability standard, going through a revision right now. 1547.2, as I mentioned before, is an application guide. It's in early stages of balloting. It's quite a robust tome of information and additional guidance on how to apply 1547. 1547.3 is a guide for cybersecurity. That's still in working group. 1547.9 has to do with energy storage deployments and application of 1547 for specifically energy storage, also in working group. think I misspoke. This was P2800, not P2030. This first one, draft standard for interconnection to bulk transmission. So that is in ballot. P2030, interoperability, and then P2030.11 is a standard that was just published that has to do with DERMS, or distributed energy resource management systems. So the intent of the standard, once again, is to give us capability for more coordinated operation under normal conditions while maintaining grid safety, grid support under abnormal conditions. Give us new capabilities for interoperability and open communications to and from DER devices, and to support new DER configurations like microgrids. The standard tries to strike a balance between needs for large and small installations. Some of these capabilities have already been enabled in parts of the US that needed them, and we're close to seeing these capabilities in widespread use, hopefully, as states implement these new requirements in their interconnection rules, and as we get these new DERs on the market. UL 1741 right now is in the final stages of being updated, so that by the end of this year we should have that certification standard, and then manufacturers will start certifying new devices, and then by next year we should see these devices actually on the market. So although the standard has only been out a couple of years, once we start seeing these devices installed, we'll start to get experience with these devices fairly quickly. Because the standard takes such a long time potentially to discuss, pre-planning for the next revision is already underway. So, and we want to get an idea of some of the potential scope and timeline, so that eventually when we do get the next revision going in the next year or so, or maybe after, we'll have to tackle some of the potential scope items to get the working groups up and running. We also want to make sure that we give plenty of time for all stakeholders to be informed, so they can build their own internal engagement strategies with the standard, and how to send working group members to it. So as I mentioned here, this is just a pre-planning effort to think about potential co-sponsors of the standard, start talking to stakeholders for those that have already looked and implemented the standard, across all of these stakeholders that I talked about, what they like and dislike about the standard, so that we can improve on the next go around. And then the end goal is to develop a project authorization request and submit it to 1547. Feel free to reach out to me if you have any input on what you would like to see. With that, I'll close and turn back to Isabel. Thank you very much.
Thank you so much, David. That was a great presentation, and we already have tons of questions coming in. So everyone, please keep your questions flowing into that Q&A function. And with that, we'll hand it over to Ravi for our final technical presentation. So Ravi, feel free to take it away.
Thanks, Isabel. Let me get my slides up. So Isabel, just let me know if you see the full slide, if you can hear me.
Yep, we can hear you, and you are in presentation mode, so looks great.
Okay, great. So thanks everyone for hanging out. I'm going to speak about the IEEE 1547 education and credentialing program primarily. So bear with me for the next 15-20 minutes. It's going to be new information, which would be helpful with the adoption of the standard, especially with multiple countries and jurisdictions looking at how do you adopt the standard and utilize it. So I want to put a quick plug in for IEEE Standards Association. I guess most of you are pretty familiar, but for those who are not, the IEEE, our core effort is around open standards, consensus solutions, but we're really truly looking at global technologies and technology platforms, promoting innovation through the standardization process, and truly to look at public safety, health, and well-being, and contributing to a sustainable future. So those are some of the goals of the Standards Association. Quick look at numbers. We have over 1,500 active standards at any given point in time. We have multiple corporations that are involved in our standards activities, not purely standards, but also conformity assessment, open source, and those types of activities. We, at any given time, most of our standards development projects has more than 7,500 people involved, more than 35,000 global participants. And we also have, surprisingly, more than 180 global agreements with regulatory agencies, other standards developing organizations, and companies, and so on. I also want to bring attention to our IEEE energy practice. They are primarily looking at power and energy related standards and other initiatives. There are three main work streams: smart energy, energy efficiency, energy infrastructure. Let me start off with energy infrastructure. We have very long-standing efforts around this with deployment of the current and past energy infrastructure, anywhere from switches to protection devices. We also help to protect utility workers through the National Electrical Safety Code. So multiple efforts there for many, many decades. But we also have the energy efficiency program that's looking at electric vehicles, large industrial consumers of energy, and addressing some of those policy goals there as well. And then looking at smart energy, which Dave spoke about 1547, and I think he covered multiple standards around microgrids, energy storage, and so on. That's ongoing work right now with the IEEE-SA. I think Dave touched a lot on this, so I'm not going to go through each one of these individually, but I do encourage all of you to visit the IEEE-SA Energy Practice page. There's a way for you to get plugged in, opportunity for you to get involved in some of this work. So please do check that out. So if you look at IEEE-SA, although our core work is around standards, we do have other programs and services that we look at. So I want to draw some attention to that. Under the Industry Connections program, we are exploring and incubating new technologies and its use. And then the standards work is ongoing. But we also have the SA membership, where we draw in a lot of experts and corporations with advanced participation options. We also have the open source program, which is relatively new, but very, very active there, work going on under the open source. We also have alliance management. We have registries where we produce unique identifiers for global compatibility and interoperability. And then I'm here to talk about conformity assessment. That's where the credentialing effort is happening. This is truly looking at adoption of the standards, providing confidence and assurance, and accelerating market adoption, either through traditional certification programs, interoperability, testing, credentialing, auditing, kind of covering a plethora of other things that sort of falls under the conformity assessment umbrella. So I'm here to speak about workforce development, and I spent a little bit of time kind of combing through the some research on this space, in this space. So I looked up a few things, and I've dropped a few links. You might be interested to take a look at these and read further into this. So late last year, the DOE, in fact, I think there are multiple funding opportunities around training programs, credentialing, where they are looking at training emergency responders, officials that are involved in solar energy and storage systems, and alternative fuel vehicles. And some of these are looking at new challenges where we need to account for an increased workforce, trained workforce, where we expect increase, like in the first example, 4% of distributed solar energy systems expected to grow by 26% in the next 5 years or so. Similarly, with connected devices in buildings growing 20% every year, and then EV and hybrid vehicles accounting for a 7.5% increase. I also looked at the solar industry specifically. There was a census that was conducted, published just a couple of months ago, where they are projecting the solar industry alone 400,000 jobs by 2030, and then with the expectation that it will need to exceed, so more than double, close to 1 million workers by 2035 if we are on the current track with decarbonization goals. A little bit more information, this one from Deloitte. In 2019, we were at about 2.4 million workers in the power sector. That's expected to grow to 3.8 by 2035, and then triple by 2035 if we kind of follow the trajectory of accelerated decarbonization. So a couple more things with the wind industry, increased by quite a bit there, 32%, from 2015 to 2016, 5.6%, and that trajectory seems to be also on the rise. We did see a decline last year due to the pandemic, some job losses, but it looks like in 2021 there was a sharp increase again, 11.7%. This was from a new report by DOE. Another interesting one I found that was more international focused, the EU policy report. Nearly 58 million people worldwide employed in the energy sector. About half of them accounted for, fossil fuel sectors, but that is sort of expected to even double by 2050, with the decarbonization policies undertaken by multiple governments. So the message I want to get across here is, with the trends that we are seeing, we say it takes a village, but this is going to take a monumental effort to kind of get the workforce ready for what's coming. So, so what is IEEE doing in relation to 1547? So this is sort of our contribution in a microscopic level, specifically focused on 1547, which is getting widespread adoption, not just within the US, but even globally. So our goal here is to create a credentialing program that will train and certify individuals who can then go out and verify DER interconnections to some of the requirements that Dave touched on during his presentations. The 1547, as we know, is technology agnostic. This program is also meant to kind of look at residential, utility scale, microgrids, etc. And we're also looking at variations based on local jurisdictional requirements. So, so one element is to look at 1547 conformance, but also look at local conditions. So one of the ways we have embarked on doing this is to bring in a set of utility participants who have not only committed time, but also are providing resources to address this huge gap in terms of workforce, understanding and making sure that proper DER interconnections happens in the field. So these are some of our participating utility partners: BG&E, ComEd, Dominion Energy, Duke Energy, Orange, and Rockland. So this is an active membership where they meet regularly to look at some of the contents that's being developed for this program. So what do we see as deliverables from this program? Number one, we want to have a standardized commissioning resource. So we want to have documentation templates and resources for someone who goes on site to commission an actual installation to be able to utilize these documents and tools. We also want to create a educational curriculum, preferably classroom style, but with the COVID situation, we are looking at remote, but ideally we would like to get to a classroom format because we think that the outcome from the training would be a lot more fruitful that way. So this training would specifically, again, focus on commissioning fundamentals, how to perform basic interconnection or understand basic interconnection agreements, and then being able to actually conduct the exercise on site. We are looking at specific levels, knowing that some interconnections are pretty simplified, varied in size and complexity. So the course would address those elements as well. And then the certification element is to certify qualified individuals who demonstrate that they have gone through the educational program and exhibit or demonstrate that they understand how to do this. So what are the benefits of this? The goal is to increase the pool of individuals that are available in terms of a workforce to do this. So any jurisdiction that's adopting 1547 can utilize these resources. It's going to be hopefully prevalent, not just regionally, but internationally. And then providing competitive, competent resource for the assessment of DER interconnections, including residential. Because that's one of the questions that's come about, does residential count in this whole 1547 conformance? And as you saw, we have some of the most preeminent utilities participating. One of the major concerns they have is the burden on the utility with the high penetration of DER interconnections, and how do we address that? So hopefully this workforce development program would help to address alleviate some of those burdens. So we want to have the applicable documentation that's going to help people in the long run. We also want to address the periodic testing inspection gap. And this is one element of 1547, which Dave touched on. So I kind of think of them as the four pillars: the type testing, the production testing, the commissioning, and then the periodic evaluation. So that's something that's being done. Maybe it's not being done in a proper manner. So hopefully this program will help to address some of that. And we also want to promote DER adoption and through the addition of knowledgeable personnel. And then we want to have appropriate resources for regulators and other authorities having jurisdiction that are mandating 1547 conformity. So how did we start all of this off? So this work on paper kind of looks like it kicked off in 2019 or 2020, but the work started way before in 2015, 2016 time period, where we started doing pilots. We did a pilot in North Carolina. It was a 6 megawatt solar PV installation site with 3-phase inverters. We did a commissioning of this site. We sent several experts. This was a multi-step process where initially there was a documentation review, then there was an on-site inspection while the system was de-energized, and then doing an on-site system performance evaluation. So during this exercise, we discovered the enter service parameters of the inverters were not correctly applied, and then action was taken to remedy that. And this exercise was completed in June 2019. We did several of these pilots. I'm highlighting a few here. There was one done in Indiana. Interestingly, this was a mixed asset site where we had solar and energy storage. Again, at that point in time, we did not have 1547.2018 published or approved at that point, so we were utilizing the amendment, 2014 amendment, and we performed the commissioning of this site. One of the findings from this exercise was the clear need for documentation resources to ensure successful commissioning. So that's one of the things that's being addressed by the program. We also went international in 2019. I had the opportunity to be in Ghana, work with the Ghana Energy Commission, as well as the Electric Company of Ghana. We looked at a solar site, utility grade solar site, 20 megawatts. They had 400 string inverters, quite unique to what we have seen in the US. So again, we did commissioning here. This particular exercise identified some grounding issues that was addressed. So the goal of this exercise was to kind of reiterated the need for this program. Interesting thing about Ghana, I have written a blog article about this. You're welcome to read it. Some of these efforts actually started at a very grassroots level, where I met with engineers from Ghana at an IEEE conference, where we engaged in some discussions which led to that pilot opportunity in Ghana. So very quick look at our timeline. Pandemic or no pandemic, lights got to stay on. We kicked off the Utility Advisory Board effort in 2020. We actually started pre-planning for this before the pandemic, and we embarked on this project knowing that this is much needed. We have right now completed the commissioning document. We have begun work on the educational content. We have pretty advanced drafts that are being circulated amongst a group of stakeholders for their input and review. We have also engaged a content creator for finalizing this content so that it could be commercialized and utilized for commercial training. And then next steps. So where we are now is we are in the midst of completing all of the educational content. As I said, there would be different levels of training based on the complexity of the interconnection. We intend to have extensive stakeholder review, and we are bringing in additional subject matter experts for their review. And then the goal is to, by end of this year or early next year, to conduct a pilot, not a pilot like the ones that I talked about, a pilot of the actual credentialing and training program. So we would be engaging some initial participants. Some may come from utilities that are participating in the program to go through the actual training and credentialing portion of this, with the hopes that we can then make all the tweaks necessary so that we can commercially launch the program by middle of 2022. So pretty aggressive schedule. We are glad to report that we are on schedule and hope to be on time for the actual launch. Just a quick look at some of the training platform work that's ongoing. We hope to deliver this in an interactive platform. People can utilize their iPads or computers to kind of follow along. But again, our intention is to try to do this on a face-to-face format. There will be a testing element to this, where we will have to conduct a test for the student who goes through the program before getting certified by IEEE. So how do you participate? If you are representing a utility, we encourage you to utilize contractors or have your engineers go through this and utilize certified personnel. We also encourage utilities to use procurement language in place to ensure that they're using certified people again. You may also engage with us on the 1547 Credentialing Program Committee, the Utility Advisory Board, the next slide will kind of give you how you get engaged. And then from an educator standpoint, we are looking for avenues to kind of grow this or expand this so that we can disseminate this training globally. So we are looking for opportunities to work with some educational agencies. So we intend to put out an RFI, and I'll cover this in the next slide as well. And then if you are representing an engineering firm, you're an electrician or commissioning agent providing services, we encourage you to participate in the certification program. We also have a conformity assessment steering committee that's reviewing this content. So if you intend to be involved, we encourage you to participate. And then when you're working with your individual customers, we want you to be able to impart that you are certified and that they should be using certified resources. So kind of coming up to my last slide here. So just a quick heads up, we are planning an outreach webinar sometime in the November timeframe, where we hope to have a speaker from DOE and some speakers from our utility advisory board who would go a little bit more in depth onto what this program is all about. We are also looking to put out a request for information, primarily focused on educational institutes, expanding the program. So I don't have that quite ready yet. So if you do have an interest, please drop an email so we can keep you informed of the RFI when it comes out. And then if you are a utility, you want to engage in the program, you want to be part of the utility advisory board, I have a link there for you to connect to join the utility advisory board. And then for everyone else, if you need more information, welcome to visit the website. It has a lot of information. It also has links to all these publications that I've listed below. Really interesting publications, some from the perspective of a regulatory commission that's looking at adoption, and then some from the perspective of utilities. So I think those will be good resources for you to read. So that comes to the conclusion of my presentation. I'm going to hand it back. I encourage you to connect with me via social media, and I'll hand it back to Isabel so we can go through the Q&A.
Thank you, Ravi. Yeah, we have some great questions already. I'll read off some of the ones you guys indicated you'd like to answer. So this question, are all control functions, and I think this one's for David. So David, I think if you're still out there, are all of the control functions, yeah, table 6 required for category B DER, even if you are only going to use one for voltage regulation by reactive power control?
Right. Yeah, good question. All of the control functions are required. That is, they're mandatory. Now, utilization of a specific control function is up to the local jurisdiction utility. I hope that answers the question.
Great, thank you. And just a reminder for everyone, in case you weren't around when we gave this instruction, you can enter your questions into the Q&A function, and that's where we'll see them. Even if we don't get to all the questions in the next 5 or so minutes, we will have a catalog of them and can follow up afterwards. So here's another one that I think is for both of you. So what is the current observed challenge of IEEE 1547-2018 implementation? And the second part of the question is, what is the next phase of work of the standard development work? Any localized technical support that can be integrated into future work so that different regions can address and clarify their outmost technical challenge, either through the implementation plan or through future standard revisions? And I think that one, to David or Ravi, maybe either of you guys.
You want to take that one first, Dave?
Current observed challenges of 1547 implementation. No, I don't want to take this one, Ravi. Let me see. I think depending on, we talked about some of the states that have gotten a head start on implementing or discussing or updating their interconnection rule. And so this happens in several of those states that already had need and then are expecting higher shares of DERs. And then, of course, some of these independent system operators like ISO New England and of course CAISO have already seen areas that or need to tackle some of these. I think the current observed challenge, one is education on the standard, and that's partially why we're giving this webinar. Is there are a lot of new types of DER. There are a lot of new DER companies. There are a lot of new manufacturers. There are a lot of new personnel. There's a lot of turnover at utilities, right? And even because of the newness of the technology, even those folks that have been there for a long time implementing this are having to cope with new things. So I would say that first and foremost, from my point of view, education continues to be a big deal and will continue. And my hope is that as folks who tackle these things at local jurisdictions will come back and share their knowledge as they roll out these implementation in all the various avenues. So I'd say that's my answer to that one.
Right. So kind of my outlook again, I mean, I'll draw comparisons to Wi-Fi. So Wi-Fi is popular, it's prevalent, people use it confidently. So one element for Wi-Fi becoming as prevalent as it is now is because there's standards around it. And along with that, there's conformity assessment. So when things are certified, Wi-Fi certified, it kind of gives the perception and confidence in the marketplace that this will work. So I think as people are looking at 1547, the workforce becomes critical. And then when people are implementing it, you want to have some form of standardized testing and performance checks. So I think that challenge sort of needs to be addressed.
Great, thank you both. So here is another one. So I think this one might be directed towards David. So does IEEE 1547 cover service restoration performed by DERs during outages? Also, is intentional islanding by DERs addressed?
Right. So now I'm thinking I should have included that slide that talks about intentional islanding. So yes, 1547 allows intentional islanding. In the previous version of the standard, it lets the point kind of open. But in the current version, there are two types of intentional islands specifically addressed. One is a facility island that is just kind of from point of common coupling backwards. So it could be a residence, it could be a campus, so forth. And then the second type of island, intentional island, that 1547 addresses is a facility island, or I'm sorry, an area EPS island. So just like the name sounds, it incorporates part of the distribution system, including some of the assets of the host utility, for example. And so these, of course, have different stakeholders and different requirements. So when it comes to the DER supporting these intentional islands, just like declaring the type of category for abnormal and normal performance requirements, you can declare the type of DER that is going to participate in the intentional island. And one of these is black start capable DER DERs. So you can do that. I would say that using DERs for service restoration is one of these hotly debated and emerging fields. So I'm happy to kind of point to some of the kind of ongoing work in that area offline. But I think that's the, I hope that answers the question.
Thank you, David. So I know we're a minute over time at the moment, and I know we did not get through all of the questions. There was a lot of really great ones. So we will have copies of it in Ravi and David. They'll be made available to you in case you guys want to do any direct follow-up. But since we're a minute over, I do want to just take a moment to wrap up. Thank you, David, and thank you, Ravi, for these presentations. They've been great. Thank you to everyone who logged in this morning and joined us. I do want to note that when this webinar closes, there will be a survey that launches about just some information that is really helpful for us in GPST to understand, you know, why you joined, how you might use this information, future topics that we could cover. So please take just a minute to answer that survey once this webinar concludes. As noted, the recording, the presentation will be made available to attendees. So I think with that, I will say thank you again, everyone. Have a great morning, afternoon, evening, wherever you're dialing in from. And thank you, David and Ravi. We'll go ahead and conclude this webinar for the day.
Thank you, everybody.
Thanks.